Hello, Wayland Middle School. Mr. Farley here for another exciting video. This time I'm going to be talking to you about solving nonlinear systems of inequalities by graphing. So just going to let you know right off the bat here, these are a pain in the neck. All right, no question about it. But I think we can do it. We'll see how we can put these two pieces together, and let's solve this inequality, this system of inequalities. It's a nonlinear system because if you look at this first one here, the red dot inequality here, this is nonlinear. It's an upside down V. We have seen this before, this absolute value inequality. So I'm going to graph it. I'm going to graph it for you right here. We know x minus 2 shifts the vertex over to 2, and the plus 4 brings it up 4. So we're talking about the vertex being here. We see that it's a negative out in front of the inequality right here. So that means it's upside down V, and it looks like this. I'll put a point here and a point here. Here we go, looking pretty good. There is our absolute value portion of this. I just also want to let you know this is a nonlinear system. If anyone has noticed, the top one here, the absolute value, clearly is nonlinear. All right, because it's a zig and a zag. It's an upside down V. The second one we do in just a minute is, you'll see here, this is a linear inequality. Even though we have one linear inequality here, because we have an absolute value inequality up here, that will classify this as a nonlinear system. So let's get back to this. Upside down V, we notice the sign is a less than. That means it's a dashed line connecting here. Do not make that solid. Very important. Okay, so there is our dash line, and that's what it looks like, absolute value. Just like we've always done before. I want you to think about this. We have to find those shaded boundaries, the shaded regions. So I'm going to plug in the origin. I've talked a lot about that. This origin right here, coordinates is 0, 0. So when I plug in the point 0, 0 into this, I get 0 is less than, plug in 0 for x right here, x is 0. 0 minus 2 is negative 2. The absolute value of that is 2, and this will make it negative 2. So now I have a negative 2 plus 4. Is it true that 0 is less than this? And yes, it is true. 0 is less than 2. When you combine those right there, you get 2. So yes, the origin is part of the solution. That means I need to shade in the region inside of that upside down V. So it would continue like this. All the way down here is what we're talking about forever and ever and ever and ever. That's your shaded region. Okay, that's the first part. Second one, we'll go in purple here. Second inequality that we have here is a linear inequality. It's in that form y mx plus b. I see a y-intercept of negative 4. I will plot that point right here. Slope of 2 tells me to rise 2, run 1. I will do that many times. A little tough to see as I'm doing this in between that shaded region that I had from the absolute value, but that's pretty clear. We see it. I hope everyone's noticing there's an or equal to here with that inequality, which means this is a solid line. All right, so there it is. Like every single inequality, we have to find the shaded region now. So this is pretty important. Again, I'm going to test the origin. It's nice and easy to use. Origin right here is 0, 0. So when I plug in 0 for y and 0 for x, I'm going to check it out. Is it true that 0 is greater than or equal to negative 4? It is true. That means the origin is also in this solution of the purple line. So I'm going to now shade in this region here. All of this gets shaded in. Ta-da-da-da. All this up here is in the correct area, correct region for the purple inequality right there. So now I have all these scribbles. This is what's insane. Taking a look at this graph, it looks like I scribbled all over the place. But what we have to look for is the overlap of both the red shaded region and the purple shaded region. Those points in the overlap. So you can see it all right in here. This here, I'm going to really darken it in. This whole area here, you can see it from there to there. Here it is. These points in this shaded region, all of them are solutions to the system. Now, this looks like it's a mess, okay? So when you do these on your own, make sure you lightly shade in the areas, okay, beneath both of the inequalities, all right, either beneath or above, wherever it might go. Just do it lightly. And then when you see the overlap of those shaded regions, that's the solution we're looking for. So I totally get it that this may look a little messy here, but this is the way you can solve a nonlinear system of inequalities by graphing. It is somewhat time consuming, a little confusing with the shaded regions, but put all the pieces together. You know what to do now. We have everything. And again, as always, if you have any questions, Mr. Robinette and I are here for you. We can help you out at any time, and hope you enjoyed the video. Take care.